All right, hi everybody, welcome back. So let's go ahead and finish up this 3.1 talking about relative versus absolute extrema. Okay, so what does that mean? So relative values, relative maximum of f is of a function f is when a value is greater than the function in some interval, right? In some brief little space. And likewise, a relative minimum is when a minimum is smaller than a function in some particular space, right? Not the entire thing, but in some small little interval, some small little space. So not the entire thing. That's why it's called relative, like relative to where it's at. But likewise, absolute is when it's bigger than everything, smaller than everything. So um, a maximum would be it's greater than everything in the domain. And minimum is when it's smaller than everything in the domain. Okay, so if these definitions are a little confusing, let's go and look at some graphs and see exactly what we're talking about. So in example 4, consider the following graphs, indicate any absolute maximum or minimum values or relative, right? So it could be either or, it could be absolute or it could be relative. So if we look at this graph on the left, right? Here we are, like we're coming from infinity, right? To me, there's really no max or mins here, right? There's no relative max. This is not really a max for min because it's just a flat line here. And there's no absolute max or min. So what I would say here is no absolute max or mins and no relative max or mins. Okay, so this graph, there's just no max or mins going on. Okay, let's look at this next example though. This one is a little more descriptive, right? So this graph is coming from like negative infinity and it's stopping at 4. So you see it's stopping right there. But let's go ahead and see what our max and mins are. So we have a min right here, right? It's at the bottom. We have a max right here, and we have another min right here. Okay, so I'm looking at this and I have two mins, right? I have a min at x equals -2, and I have a min at x equals 3. But if I look at this graph altogether, this min right here at -2 is the smallest this graph is going to be. It's never going below negative x equals -2 right here. I'm sorry. It's never going below this coordinate point right here at x equals -2. We don't really know what the y values are. So, but we do know at x equals -2, that is the absolute min because nothing is going below it. So what I would say here is absolute min at x equals -2. I don't know the y coordinate, right? We don't have them, but that is the min. So that means this min right here, this at x equals -3, that's going to be a relative min. Okay, and that's because from like here, from here to here, that's a min relative to where it's at. But in terms absolutely, this is the absolute min. And this one here, this max right here, that's not the greatest, that's not the biggest this function is going to be because this guy's going off to infinity. So there's going to be values greater than this guy right here. But relative to where it's at, it's going to be a relative max. So relative max at x equals 1. Okay, so that is how you discuss relative and absolute max. Absolute is just greater than or smaller than the entire function. Relative is just relative to where it's at. So a little self-explanatory of absolute and relative. Um, okay, let's move on to the next one. The existence and location of absolute extreme values depend on the function and the interval of interest. So what if we just have a closed continuous function, right, on some closed interval? So here we have a c d equals b. So what I want to do is kind of change some of this notation and make it a little easier to understand. So let's just say this is 1, 2, and 3, just to make it a little easier to comprehend. So here's this function, right? We start at 1, it ends at 3. So I really only have one kind of obvious max right here, right? Say like max. I don't know if it's absolute or relative yet, but in terms of this whole thing, right? Nothing is greater than this guy right here at x equals 2. Nothing's greater than that. So what I would say here is absolute max at x equals 2. All right, that guy right there. But let's go ahead and look at these guys here. So we have this guy right here and this guy right here. It's not an obvious, like, kind of loop minimum, but this is the smallest this graph is going to be, right? This is as low as it's going to go. So at here on this closed interval, right, this is kind of a different situation. This is going to be your absolute minimum. Okay. So one quick note I want to say about using these endpoints, right, on a closed interval, I'll highlight that, is that, you know, note relative maxes or mins can't be endpoints. Okay, they can be relative, right? Because this is our absolute max. Sorry, absolute min, but they're not relative, right? So they can't be, our endpoints can't be relative. Okay, so that's us checking out graphs, right? So after this, we will then shift our focus to what if there isn't a graph? And we'll do that next time. Uh, so that's it for this video. Thank you. Bye.